Recording has started. Okay, go ahead. So welcome to the training. So as we said, this meeting would be recorded. We have a question/parking lot enabled. So please feel free to post your questions on the same. So please be respectful of others in the time. You can use Zoom chat to share any interesting debates or questions if you have. Please, we request you to keep your Zoom on silent or mute mode when you are not speaking to avoid the disturbance. So please feel free to raise hands for any comments or questions, or you can type in over the Zoom chat as well. Yeah. So let me just quickly walk through the training plan. So we have planned this virtual Docker training for 3 days. So today is the day one. So as we have the audience around a good mix of who are probably new to Bahmni, who have some experience on implementing Bahmni already. So we have planned an introduction session and then followed by Bahmni Standard versus Bahmni Lite. And we also have audiences who are fairly new to Docker and some people are already experienced with Docker. So we have a basic introduction about Docker, Docker Compose as well. And we would have a quick demo on how do you start Bahmni Lite using Docker, followed by a question and answer session. And then for day two, we have planned on how do you use your implementation specific config with Docker, how do you connect to different databases and view the data tables, and then about viewing the logs. And for day three, we have a demo on setting up Bahmni standard on a fresh machine. And we would cover about how do you SSH into a container that's running and how do you set up a development environment, probably for Bahmni or one of the repos. It's just an example. It would be the same for most of the repos in Bahmni. Yeah. And then on day three, based on the timings, we would also have an introduction session on how do we run Bahmni with Kubernetes on AWS using EKS, Terraform, all this stuff. We'll have an introduction session about that as well. Yeah. So moving on. Yeah. As discussed, so the first topic would be Bahmni overview and this is Bahmni Lite versus Bahmni Standard. I'll hand it over to Akhil now.
Thanks, Mohan. Let me quickly share my screen. Please let me know if it is visible on your end.
Yes, Akhil.
It's
all right. Let me start, with giving you a brief background about Bahmni. I suspect some of the people are new to Bahmni. So a brief background, Bahmni is basically, a hospital information system, which is a completely fully open source. And, it is based on, three open source products, namely OpenMRS, which is the basic, medical record system that we use for Bahmni. And, for lab information system, it is OpenLS. And Odoo is the ERP come inventory management, billing and pharmacy management system. So Bahmni, combines all the these three together and packages them with a easy to use point of care UI. And Bahmni has been in development since 2013. And at the moment it is being used in more than 500 plus facilities in 50 plus countries. It is a very modular system. What I mean by that is that the system can run on for various adapt itself for various needs. Like for a small clinic, you do not need a full-fledged ERP. You can take that bit out. That module can be disabled, and you still have the Bahmni EMR. Or you could add a different LIS. For example, you can add another open source like Bika LIMS or Senite. You could add that and replace OpenLS, and you could still interface. So that's the basic background around Bahmni. Let me move to the next slide. Talking about the feature set, the Bahmni comes with a full-fledged clinical features It has patient registration. So whatever nodes you typically have in a hospital, Bahmni serves all of them. Patient registration. Then, in clinical, there is a patient summary dashboard, and then, there is a CPOE, which is, a computerized provider order entry. You could, the doctors could order lab orders, radiology, imaging, or, even medications, drug orders from there. And then it has also supports an open source, X-ray DICOM system, which can interface with, various modalities. And then, it has all the allied functions of billing and accounting and stock management and inventory management, purchase, sales, everything, that is required from a full-fledged ERP that is required in a hospital. So now, today Bahmni has, the structures look something like this. OpenMRS, and then there is OpenLS, there is radiology system, and there is Odoo. And then, there is a Bahmni UI on top of that. So what we did with Bahmni Lite, so this is what is included in, Bahmni standard. But what we did with Bahmni Lite is basically take Bahmni, cut down the flab, which is, not required for clinics, namely the Odoo ERP and, OpenLS, because clinics generally do not have an in-house lab or an in-house pharmacy. But clinics do have an invoicing or a billing, module. So what we did was cut down Odoo, cut down OpenLS, but added Creator as the invoicing, module. Now, Creator is also an open source, solution, and what we ended up with was Bahmni Lite for clinics, which is, compatible with ABDM, which is a very specific, India specific module, and may not be required in other countries. ABDM is basically for others, uninitiated on it. ABDM is basically India's health information exchange. So Bahmni is compliant with all the three milestones, M1, M2, M3. Bahmni Lite also comes with a starter kit in terms of forms, which are basically the templates, which are used by the doctors to record, patient history. India specific essential drugs list is loaded onto it. And then, a couple of reports which are, required for any, the basic minimum reports which are required for any facility for their, operational purposes. So, yeah. So, yeah, as I said, Bahmni Lite no longer uses OpenLS, Odoo, or DCM4G. It uses, just the Bahmni UI on top of OpenMRS plus Creator. So it's an open source invoicing solution. And another thing we did was to make Bahmni Lite cloud ready. And, I'm sure Mohan and others will, focus more on this bit to help you understand how the architecture works and, how to install and start using Bahmni on that. Yeah, these are some of the active initiatives that I wanted to share. What we have done in Bahmni Lite. So we have upgraded the OpenMRS to the latest version. This point is something you guys would be focusing on in this training. And then Lab Lite is this is another bit that we created because we shunned OpenLS. So there is no way to upload lab reports in Bahmni. So what we did was create a module which which allows the doctors to select upload the lab reports that the patient brings from third-party labs, and display that onto the patient's dashboard once uploaded. So integration of Creator, that was done as part of this initiative, and support for India's national ABDM, and a simple clinic ready configuration, that so you can say it is an opinionated view on the Bahmni workflows that are required in a clinic. So it comes already configured with that, so that the go-to-market time is reduced for all our implementers, and it is easier to configure and quicker to configure for every clinic wherever the changes are required. Other than that, we see that it will fit like 80% of the clinic needs out of the box. So that's all from me. Mohan.
I'll be taking. Thanks, Akhil. I'll share my screen. So we'll now talk about introduction to Docker. I hope my screen is visible.
Yes, Sumit.
Okay, so let's first talk about what a container is. Containers allows us to define and package a runtime environment for processes into an executable image. So when we look at containers or images, if you take a look at the Bahmni image, you'll find some of these things there. First of all, we have the application binaries. Now, what are application binaries? So we write code. At the end of writing the code, we compile the code, and we get executables in the form of jar files, var files, or if you are familiar with OpenMRS or Bahmni already, we have the OpenMRS modules, OMods, right? So you might find those binaries inside the containers. There is application configuration that a container contains. Now this is this contains settings specific to applications. Using the configuration files, we can control some of the parameters of an application at the runtime. I'll give an example. Let's say we are running an application and we can pass the database connectivity URL through this configuration file. We can change that later on. There are other dependencies like, say, libraries, tools, etc. System configurations like system files, directories, environment variables, etc. All of these form a container or a Docker image. Now, containers use operating systems to isolate the processes, networks, and file systems. So at the overall, when we look at the containers, we find them to be self-contained servers. So all of these containers are isolated from each other, and isolated also from the host machine that is running the containers. And we can think of containers as being immutable objects. Once we build a container, we are only supposed to run it. We cannot change it at the runtime. Yes, we can control some part of the at the runtime, but overall, if we look at the containers, we can say that these are immutable objects. Now, why do we use containers? So first of all, it increases predictability of the state of our environments. Now, what does this mean? Let's say I'm working on an application. I run it. I make it run on one of the environments. I can say that, okay, this is running because I'm using certain operating system with this version. I'm using these many dependencies. All of them, the versions are like that. I can then take all of those pointers and create a container out of it, publish the container. Later on, if anybody else wants to use this, they can just run the same container, and we can hope that the state that I achieved in the previous environment, I can maintain that state here. This is because all of the things that are needed to run the application, we provide the exact same environment inside the container. So that's why we can say that it improves the predictability of the state of environments. Now, this also depends on the host machine's architecture. But overall, we can say that, okay, our state can be predicted. So it also simplifies the process of moving applications or softwares between different environments. Again, because of the same thing, all of it is pre-configured inside the containers. We can create multiple developer environments quickly. We can avoid the dependency hells, like so we have different versions of the dependencies. We don't need to, yes, we can, I mean, document it, but we can make sure that we are using the exact same versions of all our dependencies once we publish the containers. Now, this is very useful for microservices. Bahmni uses this microservice architecture. We have many different services running on different containers. And using containers, we can fit in more containers on a single host as compared to the virtual machines. This point can be elaborated in the upcoming slide. But before that, let's quickly go through the architecture of Docker to see how it works. Now, when we talk about the architecture of Docker, there are three important components. Let's first look at the Docker host, which we see is in the middle part of this architecture. So it's the brains of Docker. It contains Docker daemon. Now, what does Docker daemon do? It listens to Docker API calls. And it is its job is to manage these containers, images, volumes, networks, everything. Now, second most important part is the client. Now, we use the client to interact with Docker daemon or the Docker host. Let's say we run a command like Docker run any image, say Docker run Nginx. The client sends that API request to Docker host. Docker host listens to the request, responds by first checking, do I have this image? Because it's supposed to manage the image. Do I have the image present on the local host? If it does find an image, it starts a container out of it, runs the container. If it does not find the image, it reaches out to something called as a registry. What is a registry? This is a place where we store these Docker images. We build the images and then we publish them on some registries. One of the most common registries where we are also hosting our storing our Bahmni images is the Docker Hub. Now we can control a registry. We can choose whether we want to make our image public or not. All of that can be controlled. So that's the overall architecture of how Docker works. Next, let's look at what is the difference between containers and the virtual machines, because earlier, prior to using containers, we used to use virtual machines. What happened in virtual machines is that we had the base infrastructure on top of which we used to install an operating system. We call it a host operating system. And if we look at the virtual machine, on top of the host operating system, we have a hypervisor. So hypervisor used to run the virtual machines. It used to provide services like isolation, partitioning, etc. And then on top of the hypervisor, a virtual machine used to put a guest operating system. Now, here we can see that there's a guest operating system and a host operating system, two operating systems, and on top of the guest operating system, virtual machines used to put the libraries or other applications. Now you can see there are lots of layers involved, right? So this looks like complex when we compare it with a container. Container its architecture is simple. So there's base underlying infrastructure on top of which we have the host operating system. Now here we don't have the guest operating system, because what containers do, Docker does is containers overall does is that it utilizes the host operating system's kernel and uses that to run the applications. It does not need a new guest operating system on top of it. And then using container engine, it provides us the isolation. So you can see the overall structure becomes much more simplified, less number of layers. The image size, when we compare virtual machine image size with a container image size, it's a lot less. And it's simple to manage. It boots up quickly. So those are the few benefits that we get from container and virtual machine. Now we'll go through some basic commands, and I hope you can see my terminal. Okay.
Yes.
Yeah, we'll go through some basic commands that we will use when we are, installing Bahmni or using Bahmni with Docker. So first important command I will look at is Docker version. So Docker version is a command that we should first of all use. Now this tells us what version of Docker we are using. Why this is important? Because we want to make sure that we are using the latest version of Docker always. So when we build and publish the Bahmni images, we test them on the latest version of Docker. So if you get into any of the errors or trouble, the first thing you should look at is what version of the Docker I'm using. You should be always, we should prefer to be on the latest version always. Next important command with Docker version is the Docker compose version command. Now, Bahmni, as we will see later, Mohan will show us the demo. We run Bahmni images or containers using Docker Compose. Now, it's preferred that you should be using Docker Compose version 2 or above to make sure that everything works smoothly. Next command we'll look at is Docker pull. Now, what does this do? When we type Docker pull, any image name, it reads out a registry and downloads the image for us. Again, example, we try to pull Nginx image. Now, when I hit enter, what will happen is, this is my Docker client, right? It will send a request to my Docker host, the Docker daemon. Docker daemon will look first locally. Is the image present locally? If it finds, okay, in my case, the image was there and it was up to date. So it did not download a new image, but if it finds that, okay, image was not present in my local, so it will reach out to a registry and start pulling the image. Now, I can also mention something called as, the labels here. Latest is the default label. There might be other versions of Nginx that you might use. Now, all of that can be controlled by using the image labels. So that's about Docker pull. Next, we can look at is Docker run. Now, once we pulled an image, which means the image is present already, we can use the Docker run to actually run that image. So giving an example of Nginx, I can say Docker run Nginx latest. What it will do. So first of all, again, the request reaches to the Docker daemon. It will make sure that the image is present. If it finds that image is not present, it will again pull the image. So when we do Docker run in the background, it's kind of doing a Docker pull first and then the Docker run. So if I hit enter now, what it will do is it will start my Nginx image that I just downloaded in the previous step. So what I'm seeing here are the logs from Nginx container, right? So it says that worker process has started already. Okay, now how do I make sure that, okay, is it running or not? We'll do something like this. I'll reach out to my browser. I'll say localhost 8080. So it's not able to make this connection. Why is that? Because when I hit localhost 8080 from my host machine, what I'm trying to say is I'm trying to connect to port 8080 of my host machine, right? But the Nginx container that we just ran is not running on it's running inside a container. So in order to reach Nginx's port 80, we need to map my host machine's port to the container's port, right? Now, in order to do that, we can amend the previous run command and we can add something called as a flag for port mapping. So I'll map 8080 from my host to 80 inside the container. I'll hit enter. Again, the process started, but this time, since we are mapping these ports, if I hit refresh, I can see that I can make the connection. So I can reach the containers port 80 using that mapping, right? Now, another thing here is, okay, now everything is running smoothly, but the problem is once I run this image, I'm not able to use my terminal again, right? It has locked out my terminal. I can only see the logs. And if I do Control C, it will just stop the container from running, right? So if I do Control C, nothing is. Now, how do I see how many containers are running currently? For that, there is a command called as Docker PS. So right now, no container is running. So I will run the Nginx container again, the run command, but this time I'll put something called as -d quickly. So it will start it in a detached mode, right? Now I have the free control of my terminal, but I can still use the Nginx container, right? So that brings us to the next command, which is Docker Okay, so I can see that Docker PS, this container is running now. So how do I stop this container from running? Simple command is docker stop. Now I have to give either the container name or the container ID, right? You see container ID and a container name. So now the name here, you can see it has added a name, eager, devinci, something. Now this is randomly generated. We can control, we can give it a name at the time of starting. I can say Docker. So, okay, before that, let me stop the previous container. So for that, I'll do Docker stop and I'll give the container ID. This is my container ID. So this stops the container. Now I'll start the container again, but this time I'll give it a name. My Nginx. So it runs this container, but this time with this name, right? My Nginx, I missed the M, sorry. So the idea here is to see, okay, to run a single container, you can see I had to add lots of flags, right? And this is what will be simplified later by Docker Compose, and Mohan will be giving us a review about that. Okay, so we can look at another command called as Docker restart. Now Docker restart will restart a container. When do we need to restart a container? It can be, I mean, it will depend. Okay, something changed inside the container. We changed some configuration. I want to restart a service. I can do that using Docker restart and then giving a container name or container ID. It will simply restart my container. And this time, if I check, how do I know that it restarted the container? Simply by looking at this created status. Previously, it says that it was created 3 seconds ago, and later on, the times will change if the container restarts. So anyways, after the restart, the next important command, which we will be using more often, is the Docker exec command. This allows us to execute some commands on the container, right? I can say Docker exec. I need to give a container name or container ID. And then I can say new file. For example, I'm running this command on this container. What it will do is it will create a new file inside the container. Now, if I do ls here, I'll see that on my host machine, I don't find that command because this command ran inside the container. Now, how do I check whether it created the file inside the container or not? In order to do that, we can use the same exec command, but this time we will not execute a command like this, but we will try to launch a shell interactively. So in order to do that, we'll do docker exec -it for interactive. And I can use a shell. So this Nginx is based on a Debian operating system. So I'll do bash shell. So right now what you see is this log, right? Root at the rate of the container ID. So I'm inside the container now. If I do ls here, it shows me what all files are inside the container. And I find that my new file is already here. Now, why this is important? So in the first slide, we talked about all the different things that we can find inside the container, right? One of them, so here we can take an example of this page, right? The index.html page. So we know that Nginx stores in this file at this location. So we'll go to this location. And I find that this index.html file is here. I can change it. I can add some other customized index file or anything. So basically, that's what this docker exec command does. It helps us to execute various commands inside the container. I'll exit it. And now I'll do docker ps again. I'll see that my container is running. Now, okay, I want to check the logs of this container, right? How do I do that? There's a command called as docker logs. And again, I need to provide either the container ID or the container name. By hitting enter, I see the logs here, but okay, logs are gone now, right? How do I follow the logs? I'm working on something, I'm debugging something. I want to follow the logs. In order to do that, we'll just add a new flag, -f, just will follow our logs. And if I hit refresh from here, and we'll see that our logs are getting updated, right? So that's the docker logs command. Next important command would be docker volume. Now this can show us, when we talk about Bahmni's containers, there are lots of containers, and we want to persist some of the locations in some of the locations inside some containers to make sure that our changes don't go away when the container is down or restarted. So for that, it creates something, we use something as called as volume mounts. Right now, I don't have any volumes up, but I'm sure that once we see the demo, we'll have lots of more volumes to look at. So we'll just look at it there. So these are some of the basic Docker commands. There are others as well. You can refer to the documentation to look at those, but these are mostly which we'll be using in the demo. So that's it from the basics of Docker. I'll hand it over to Mohan now.
Yeah, sure. Thanks, Umer. Okay, so now I hope everybody has got a glimpse of the Docker commands and what is Docker, how does it work. So let's quickly jump into the Docker Compose configurations. So let me share my screen again. Go into slideshow mode. Yeah, so hope my screen is visible. So what's Docker Compose? So Docker Compose is a file specification that allows us to run multiple containers as a single service. So there are a couple of challenges that Docker Compose solves us. So as we have seen, for running each and every container, we need to run the Docker command. That would be suitable, for example, if you have a single web server or say a static container that's just running. But in case of applications, like let's say, for example, if we say Bahmni, we have different applications. Like let's say we have a front end, we have a back end, and we would have a database. So if that's the case, it's very difficult to run each of the containers separately, link them together, and achieve container to container communication. So that's where Docker Compose comes into picture. So Docker Compose allows us to start multiple containers at the same time, and it creates a common network so that containers can communicate with each other. And another benefit is now if you run individual containers as commands, you need to document it and you need to follow the command. But if you take Docker Compose, it allows you to write the container configurations as code. It will say you can define what services you want, what's the image it uses, what's the tag it would like to use, everything you can specify. So a simple example would be, let's say you have a Node.js server and you have a MySQL database. You want both the containers to start to manage with a single command, you can use Docker Compose. So let me move ahead. So yeah, so the base of Docker Compose is the YAML file, which we can use to configure our application services. Then once you have the Docker Compose file added with all your services, you can use a command to create, start, stop, restart in the containers in your configuration. A typical Docker Compose file would look something like this. It will say version, which is the Compose file specification version, and we'll have a set of services. For example, this example shows how do you run a hello world image with a specific tag, how do you expose ports, and how do you start a second service. So once you have the Docker Compose creator like this, you can then do Docker Compose up -d, which would start all the services in the container. So I'll share this link. You can refer this for more in detailed explanation. So another example of a Docker Compose file would look something like this. We have a Node app which is running, and there is a Redis image running. Yeah. So let me just quickly show, create a Docker Compose file, and then show how what Umer did with Docker run commands. Let's try to replicate with the Docker Compose file. So I'm in a folder now. Let's say we'll create a file. I'll create Docker compose.yaml. So I'm creating a file. It's an empty file. So let's get into an editor. Maybe I'll open it in VS Code. Right. We have the Docker compose file now. So let's get to the version first. We'll add the version and we'll say version specification as 3. So the next step is we would start from the services. So I'll create a service. So this follows YAML indentation. So whenever you write a YAML file, indentation should be taken care of. So now let's say I want to start a web server. Just to say web server, I'll say web server. So whatever service we start, the first one would be image. So what is the image that this is going to run? For example, now I'll add an image tag and I'll just say engine. Yeah. So now we have the bare minimum Docker Compose ready. So now in order to start this Docker Compose, I'll go back to my terminal and So one thing to note here is whenever we run any Docker Compose commands, it's better that we are in the directory where the Docker Compose file is located. So I have my Docker Compose file in this directory. So let me fire the command. I'll just say Docker Compose up. So if I say, as we can see in the logs, first it has created a network and then it has created a container named as web server. So we can see the logs are coming up here. The live logs are coming here. So now let me go to my browser and I'll just say localhost. Localhost :80. By default, it should run here. But we are getting a connection review. This is because, as Umair mentioned, the container's port is not mapped with the host machine's port, so that we are not able to access the container. So now, let's say I want to expose the container's port to my host machine. I'll go again here. I'll just say ports, and I'll say my host port would be. I just want to expose it on host port 80, as well as the container port would be 80. So now once I made this configuration, I'll go back again and I'll do Control C. I'll just do Docker Compose up again. So now we can see that it automatically recreates the container. As the configuration, Docker Compose configuration has changed, by default, Docker Compose would recreate the container whose configuration has been changed. So now if I go back to my browser and hit enter, we can see that the container is exposed. So now let's say, this is occupying my terminal, right? Same. Here also we have the flag to run the containers in detached mode. Yeah, so now I'll say Docker Compose up -d. Now it will just say container is started, it's running, and now I got the terminal back again here. And now still our application is accessible. Now let's say I want to make some changes in my Docker Compose file. So for example, I have port 80 already occupied. I want to expose my Nginx web server on a different port. I'll just go here and say, okay, instead of 80, map the containers 80 port to port 81 on my host machine. I just say this. I'll go back to my terminal, and if I say Docker Compose up -g again, it will automatically recreate the web server container. Yeah. So we have the container recreated. So now if we go here and if I hit again, so it says connection reviews because the port mapping has changed. Now I'll specify the port as localhost :81. So now we can see the container is accessible again. Yeah. So this covers the basics. So for more detailed documentation, you can follow the official Docker Compose documentation. I'm sharing the link on Zoom chat. Yeah. Okay. So now moving on to the next slide. So what are the benefits of running Bahmni on Docker? So we have listed few of the benefits. So the first thing is when you go with Docker-based approach, it's platform independent. So before Dockerization, we had a requirement for Bahmni that Bahmni can be installed on a CentOS machine. So for other platforms, we have some other options like either we can install with a Vagrant box or a virtual machine kind of. So now once we use the Dockerized version, it's platform independent. Whatever OS you run, you can just run the containers on top of the OSs that you have running. And even here with the latest releases, we have the images compatible with ARM processors as well. So some of the community members has been using ARM machines. So now the Docker images that Bahmni publishes is ARM processor compliant as well. And the other benefit is it eases the installation procedure. All the dependencies and packages come pre-installed with the container image. So it's just that you pull the image and start off the container. And then it allows you to do easy upgrades, and it allows you to easier customizations. Like you can build an image, Bahmni image, you can build your own custom image using Bahmni as the base image. And then it can be easily deployed on any cloud platform and it can be scaled very easily. Yeah. So let's move on. Yeah, so now let's have a demo on running Bahmni Lite with Docker. So before we get into this, let me stop the recording and start again.